Hello everyone. Today let's solve the problem number 189, rotate array. So what the question states here, we are given an array nums. You can clearly see here, this one I'm speaking, array nums. Sorry, this one I'm speaking, array of the nums, right? Nums array and a number k. This is also of the type integer and the number k. What we need to do, we have to rotate the array to the right. So we have to rotate the array to the right. This one to the right, right? uh, to the right by k steps in place. So we shouldn't make use of any extra space here. So you would have already guessed, whenever there is in place, we'll be going with the 2 pointers where we're dealing with the arrays, right? So you would have already guessed the approach. So we are given an array nums and a number k, and we have to rotate the array to the right by k steps in the place, right? So here in this case, let's come to the first example. So just give me a second here. Let's come to the first example. Here we have 1 2 3 4 5 6 7 and we have k equals 3, right? So just give me a second here. Yeah, here in this case what we will do, we have k equals 3, the last three numbers we need to consider, and we have to push this one to the beginning of the array. So the output has to be 5 6 7 because k has, we have been given k equals 3. K is an integer. K consists of the integer value, right? So k equals 3 we have been given, last three elements we have to consider in the array, and we have to push that one to the beginning, right? So here it has to be 5 6 7 1 2 3 4, the same output they have mentioned here, right? Rotate one steps to the right, so this will be 7. Next we will be rotating 6 here, and then we will be rotating this one, or we'll be pushing this one. So this will be, what happens, 5 6 7 1 2 3 4 will be the final answer, right? So that's what they have given in the explanation as well. You can just go through this one. So let's come to the second example. Here we have minus 103 and 99. K equals 2 we have been given. First we'll push this one to beginning, and then this one to here. So this has to be 399 minus 1. Yeah, 399 minus 1 and 100. So that's what we have got in output as well. Same thing they have given in the explanation part. So they have given us wonderful examples just for the sake of understanding, right? I hope the question part is completely clear, easy to understand. Let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. Let's come to the first approach part here. Before discussing the approach part, so we will be going with the 2 pointers. Just keep this in mind. The approach that we'll be making use of here is 2 pointers, as we don't have to use any extra space. So let's go with the 2 pointers, right? So I hope this is clear, because when we don't have to use the extra space, apart from the 2 pointers, means left and right pointer, will not be making use of any extra variables, right? When we make use of the 2 pointers, this will be this advantage will be having basically. So let's come to this part here. I'm speaking of the class solution, this part, right? So, sorry, I'm speaking of the approach part, so not this one, sorry. So here first, we are considering the first example. We have already discussed this one, so it will be easier to understand, right? So here we have k equals 3, and the numbers we have in is this one, original array, that is 1 2 3 4 5 6 7, this one, right? So first step what we'll do, we'll reverse the entire array. When we reverse the entire array, whole array, when we reverse, this becomes 1 2 3 4 5 6 7 we have, this will be 7 6 5 4 3 2 and 1, right? So when we reverse the entire array, this becomes 7 5 6 4 5 3 1. The second step is we will reverse the first k elements in the sense, this one k in this place, k we have been given 3. We have been given k equals 3. So when we reverse this one, this will be 5 6 7, and 4 3 2 1 remains as it is. So we are reversing only first k elements, right? K here, the value we have been given 3. The final step is we will reverse this part. So we'll reverse the remaining n minus k, nothing but the 4 elements in this case for the first example. So this will be 5 6 7. When we reverse 4 3 2 1, it will be 1 2 3 4, right? So this will be 1 2 3 4. So the output that we got here is 5 6 7 1 2 3 4, which is equivalent to the output that they have mentioned in the first example, 5 6 7 1 2 3 4. So our approach works absolutely correct, right? Our approach works absolutely correct. um, how we'll be writing the code basically means, we'll be making use of the helper function. One helper function will be making use of the this one, what do you call, mm, we'll be making use of the any helper function, and then to reverse for the reversing the numbers, we'll be making use of the helper function in the main function. These two steps we'll be doing while writing the code. Before writing the code, accordingly with the approach, let's discuss the complexities first, right? So what would be the time complexity? The time complexity would be big of n, because we will be traversing the array three times, right? Each traversal takes big of n, we know that one. We reverse the array three times, right? Each reversal takes big of n. So overall time complexity would be, here in this case it would be big of n. So overall time complexity would be big of n, right? So what would be the time space complexity? The space complexity would be big of 1, because we are doing this in place swaps using two pointers, right? So we are not making use of any extra this one extra space. So the space complexity would be big of 1, and the time complexity would be big of n, right? I hope the complexities part is completely clear. I hope the complexities part is completely clear. Now, as we are completely familiar with the approach, let's start writing the code. So initially, what shall we do? We have to store the length of the array. We have to store length of the array. So here, let me go with nums dot length. The next step is, in case if k is greater than n, then we have to take the modulo to avoid the extra rotations. We have to avoid the extra rotations, right? They have given in the question. So we need to consider the constraint. This one, we have to consider the modulo to avoid the extra rotation in case if k is greater than n. So here I'll just give k equals k modulo n. This is fine. So let me do one thing. Let me come out of this one entirely. So let's write the helper function. So we will be going with the two pointers reverse helper function, as I've said it earlier during the approach. So I'll just go with private void reverse. So this one will be int nums. This one will be int left. This one will be int right. So left and right of the pointers will be considering along with the nums as parameters. So this is fine. First step here, as we are going with the this one two pointers, will loop until two pointers meet. So that is nothing but while left less than right. This is fine. So within the within the while loop, so what we'll do, we have to swap the nums of left and nums of right first. So let's consider the temporary variable for the swapping purpose. So what we'll do, this will be in temp is equal to nums of left, and nums of left, we assign this one to nums of right, and the final step here is nums of right. This one we assign this one to temp. This is fine. So the next step is, let's move the left pointer right, and we have to move the right pointer left. So nothing but we have to increment the left pointer and we have to decrement the right pointer. So this is it for the what do you call, this is it for the helper function, reverse helper function. So let's make use of this one in the main function, right? So what we need to do, we have to reverse the entire array first. These are the three steps we discussed in the approach. If you remember the main three steps, we have to reverse. First step was to reverse the entire array, then we reverse the first k elements, then we reverse the last n minus k elements. First let's reverse the entire array. So let me make use of the reverse here. Nums 0 0 nothing but left, so n minus 1 right pointer. So this is fine. So let me copy the same thing. Let me paste it two times. So here let's make the necessary changes. First, we are successful in reversing the entire array. Next, we have to reverse the first k element. So this will be k minus 1, right? So the final step is, after reversing the first k elements, we have to reverse the last n minus k elements that is left. In our case, first what we did, we reversed this entire array. Means the first part was 7, we got the output 7 6 5 4 3 2 1. The second step was we reversed the first k element. So this one, the line number 7 I'm speaking of, right? It was 5 6 7 4 3 2 1. Then the final step was 4 3 2 1 was, we have to reverse the 4 3 2 1, right? So after reversing the 4 3 2 1, we got 1 2 3 4. The third step is, we have to reverse the last n minus k elements. So this one will be nums k and n minus 1. Just we are reversing the last n minus k elements, right? So this is it for the code. Let me format the code once and let me hit the run button. I hope this works, man. Let's see. So yeah, you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct, right? So I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.